Hi and welcome. This is an interesting project. So I've got to make some clamps here. They're going to hold a plate onto some hand railing on a boat to hold a Starlink dish. So the machining is pretty simple, but the project's kind of interesting, and there's some considerations about where to place the Starlink receiver antenna that will affect how well it can receive signal from the Starlink satellites and transmit back to them. And it's not as simple as it might seem, especially if your boat happens to have radar. First up, we're just going to clean up this little piece of scrap aluminum I've got here. These clamps are going to be a little bit beefy, not super big, huge. I don't know why I'm doing this, I just couldn't help myself, to be honest with you. Pretty shiny pieces of metal are what I love. Even if the first time they go out, they're going to end up getting corroded patina on them. When you don't care about the dimensions of the material, but you want a hole centered, I just work off center lines. I didn't even bother measuring the part because its absolute dimensions really did not matter. The DRO makes finding this very easy. It's not a super precision operation either. And here we are in the center, that I can find again very easily, and I don't have any idea what the actual dimensions of the part are. The boat's railings are made from Schedule 80 1-inch aluminum tubing, which makes the outer diameter 1.32. However, part of my issue here is that where the railing comes to a point at the bow of the boat, the railing itself is bent at an angle. So I'm going to drill my holes oversized, even though this is not very thick, so the angle that's going through here, the bend that's going through here shouldn't be all that much. I haven't actually measured it because I don't have the boat near me. It's at my brother-in-law's. What I'm going to do is I'm going to use an annular cutter to first cut out the majority of the material, then open it up to about 1.38, 375, maybe as much as 1.4. That's just isopropyl alcohol. If you pack a lot more, you can prevent this bee's nest from forming in the first place, but and we're there. Nice chunk of material. I love how annular cutters leave this center slug. So this is a Criterion boring head, and I had some Chinese made boring bars that had flats on them. But when you tighten the screw down to hold the flat, it aligns the cutting bit, the carbide insert, in a certain spot, and it was designed for the Chinese heads. It actually was too far twisted this direction, which meant that the back of it would rub before the front even cut, so you'd never get a good cut with the boring bar. So I had to buy some new ones that were round that didn't have flats in them, where I could have just gotten Criterion. I'm sure plenty of you are saying you should have just gotten the quality ones to begin with. I originally started with the Chinese boring head, so that's where those other boring bars came from, because they came with it. So this one I can set up myself, and I can set the amount of relief I want. You just got to make sure to tighten this adequately, and then if you're doing a critical project, you could potentially have an issue where this would twist on you if you didn't tighten it enough, and then you'd end up with problems. I'm currently feeding this by hand. And I'm getting a pretty decent finish, even though this isn't a positive rake insert. Normally I replace on the boring bars, I replaced the insert with a positive brake insert. So you can see if I rotate this, I can put the front tip of this more towards the inside of the radius versus the outside. If you twist backwards, it sticks more out, so you can actually control the amount of relief you have behind the cutter, besides what's built into the insert itself. And so you got a lot of control. As long as I have this guy centered on here, I might as well put the saw cut line, which is going to run this way. So that's where the saw line is going to go, and then I'm going to drill through to this side all the way through. Decided to go with through holes and nylock nuts, so I just got to drill a hole straight through. Using the scoring line that I put in there, we'll just cut this guy in half. Drew on the metal plate where the poles are going to, the outside edge of the hand railing is on each side. So these will go here, and then we'll extend this curve out to here, or we'll put a cutout one way or the other. Here's one side, here's the other. They're kind of, it's kind of big. And then the satellite base plate will mount here. All right, so here's the boat. And you would think that maybe the best place for the Starlink receiver would be on top of the cabin, but up there is also a radar, which is a transmitter receiver combination. In a similar portion of the spectrum, one thing that comes to mind is that the radar could put out enough power to damage the receiver section of the Starlink receiver, since it's a high sensitivity receiver, but at a minimum it could swamp it. So the other options would be to put it back here, but the Starlink receiver is 140-degree angle of view of the sky, and that would run into the cabin even all the way in the back, so you'd have to raise it up. So the other solution for this particular boat is to put it up here. And so that's what we chose to do, and we're going to mount it right on the handrail up there. Setting the mounting plate up at the very front. I'm going to put the clamps on, clamp them in place, and then drill through the mounting plate, and then cut off the excess material. There we are mounted. Then the Starlink base plate goes on top of that, and the Starlink antenna goes on top of that. It will be sloping, leaning towards the front of the boat.